We'll go from the current slide, and I may even turn on the projector today. Let's see if that will work. Yeah, let's try. While that's coming on, let me go through just a couple of announcements. One you've heard, one I know you haven't unless you've gotten this information elsewhere. Don't know if y'all are involved with taxes or not, but do you have a tax problem you haven't been able to resolve with the IRS? The Taxpayer Advocate Service, as a business or an organization, will assist practitioners in person at this upcoming Problem Solving Day. That sounds like a good name for a math day, doesn't it? Okay. What it is the Taxpayer Advocate Service Problem Solving Day here at Lawson State Community College, here on the Bassmer campus. Where? Over in the Millsap building. That's the building on that side of us, kind of a whitish looking building that sits outside the loop, so to speak. So you can see it when you drive around. At the One Stop Center, which is on the main floor, which is not the lower floor, the main floor up above. Okay? When will this be? Tuesday, March 31st. Now that's the Tuesday after spring break week, I think, isn't it? Okay. So the Tuesday after spring break week, it'll be from 9 in the morning until 2 in the afternoon. Okay? The partners are Lawson State Community College Workforce Development, the Alabama Asset Building Coalition, the West End Community Volunteer Income Tax Assistance that do actually free income tax preparations. Okay? So who can you contact? There's a Miss Brenda Thomas. I think she's over here at 3502-929-3502, or Miss Dorothy Henry. We have a Dr. Henry. I don't know if her name's Dorothy. So anyway, I think they're probably both over in the Millsap building. The Taxpayer Advocate Service, TAS, will be available to assist taxpayers with tax problems they've been unable to resolve on their own with the IRS. Our goal is to provide personalized, step-by-step guidance. If your tax problem meets our criteria, we'll assign a case advocate to work directly with you. The Alabama Asset Building Coalition, AABC, supports IRS's VITA, which is Volunteer Income Tax Assistance, and TCE, Tax Counseling for the Elderly programs. Not too many of you qualify for that probably. But here's the point. This is not just for you. This is for the community. So if you have family members, friends, church members, relatives, anybody out there who has a problem, you know, they've had an issue with the IRS, they try to get it resolved, they haven't been able to, tell them about this. This is free for them to come. Tuesday the 31st of March, this month, okay? Let's see, where was it? Yeah, the AABC will be available to help taxpayers file their 2018 and 2019 state and local federal income tax returns. So it's not just for federal, it's for state as well. Some conditions apply, and you can find them on AABC's website. The Taxpayer Advocate Service is an independent organization within the Internal Revenue Service. So the TAS is part of IRS, but they're there to help you, and they want to get things resolved. The TAS helps taxpayers resolve tax problems, recommends changes to prevent future tax problems, and protects taxpayer rights. TAS's services are free, absolutely free to taxpayers who are, number one, experiencing a financial hardship or having financial difficulties because of a tax problem, trying but haven't been able to resolve an IRS tax problem, or believing an IRS system or procedure isn't working. So if any of those fit, any of those, in any small way, have them come and visit on the 31st. Learn more about TAS at www.taxpayeradvocate.irs.gov. It's a lot of blah, blah, blah. It'll be up here in the front. You can get it, get the information, get the websites, pass this along, let people know. And the one other issue was, if any of you were in the first mini-term course, they were late opening the student course evaluations. I imagine they're still open, but they probably won't be open for very long. So try to get your student course evaluations done for those first mini-term courses, not for the full-term courses. Those are going to be open later. But the first mini-term courses, get those done. If you know of anyone that was in a first mini-term course, let them know that as well. And the other issue that comes with that is, and I've mentioned this every time I've made this announcement, is at some point they'll ask for midterm progress reports. And as I look at this class is probably one of my best Math 112 classes about getting things in and getting them done fairly early. And I'm only missing 1, 2, 3 first quizzes out of a class of 29. That's not great to have that many missing, but it's better than I just about any time have. So please get your quizzes, and I'm preaching to the choir here because y'all got yours in. Those 3 people aren't here. Well, one of them is here. Okay? But anyway, and then several of you, a few of you have finished your first test. A lot more need to finish your first test. And some of you said last time that you were going to come to the Birmingham campus on Friday to finish it, but I said be sure to tell me Thursday. Right now I don't see any of those people here. Or at least a couple that I remember are not here. Now, we've also had 2 people come in while I was making announcements. Let's see if I can find you here. Sean, all right. Okay. Here. And there you go. Courtney, right. Did anyone else come in that you haven't heard me call your name? Okay. Good to have y'all here. Sorry the announcement took so long, but it sounds like a very, very good, timely, pertinent program. I wanted you to know about it. All right. Where we were, any questions on anything we've covered so far? Okay. Where we were last time, we're in Chapter 2, Polynomial and Rational Functions. Still in 2.1. Hopefully we'll finish this today. Quadratic functions and models. Okay. For some reason I have turned the page. Okay. There we are. Yes.
Will we have a chance to have extra credit? I know we have the essay that we have
right.
to turn in, but just do we have any time that we can make up a test that we kind of scored low on, or can we just have extra credit? Because I need this class for it.
Okay. A couple of answers that you hit one of them. Your research paper is a great opportunity to bring a score up. Secondly, most people haven't finished the first test. If you do well on the part you're missing, that can bring that score up. Number 3 is I do drop your lowest test score. So do quite well on the next test or 2, and you're in really good shape. Okay? So you've still got quizzes to go. They will help bring your score up because those are take home, and you can work on that. And then, of course, the final exam, it's going to be easy, and that's a great way to improve the score. And ask lots of questions. Use the materials in the book. Some of these examples are located at larsonprecalculus.com. Every checkpoint is at larsonprecalculus.com. All of the homework exercises, the odd number exercises, are at calcchat.com, and a few from most of the sections are at calcview.com. I mean, they show you everything there, interactive. So use the resources and ask me questions. In class, out of class, wherever. Okay. But yeah, there's lots of ways you can bring up the scores. Okay. Hope that answers it. Okay. All right. Now, if my memory's right, like I was saying, we're in 2.1, almost through with this. We're on page 118. At least that's where I had my mark. And we had done most of example 3. It's not on the slideshow, but we had done most of example 3. So just as a rehash, do you need to see what we did again, or are you okay with just picking up where we left off? Example 3. Okay. So sketch the graph of f of x. Let me get my pen set up. And let me also say this. I've said it to a couple of you individually, but I'll say it to the whole group. Just about across the board, the lowest score in this class is almost always that first test. And part of the reason for that, the first chapter is dealing with functions. And I've taught Math 100 before, and maybe that much of functions are done in Math 100. So it's a brand new subject. And I realize it's kind of new to you, and if you're not digging in it pretty carefully, it can slip on past you, which looked to be what was happening to some extent. This chapter, chapter 2, is 2 types of functions, mostly polynomial functions, which are the easiest kind, not functions in general that covers a whole board, but just polynomial functions. So those are a little more digestible, okay? And so we're not doing as broad of a thing, a lot more specific. And the steps and the guidelines are very, very consistent. So I hope you'll find, and most people do, find that the second test is much easier. Not that it's an easier test, but you're in the groove, okay? And you usually do, the students usually do better at it. So don't let that first one throw you that badly. I too was somewhat disappointed in it, feeling like I just had not done a good job of teaching, but please hang with it and keep working. So here's the function, f of x equal to minus x squared plus 6x. And since I know I'm going to do it anyway, I'm going to put my blank there and then do the minus 8 way out there. Okay? What I'm doing here is isolating the terms with x in it and then putting the term without x in it, the constant term, off by itself there. Okay? Now, I've done that. What's the next step? Okay, factor out the a. A little bit of review here, just to give you the idea. Remember, in our good old standard form for a quadratic equation, we said, and this is a quadratic function though, so this isn't standard thing, but this was ax squared plus bx plus c. So a here would be minus 1, b would be 6, and c is minus 8. All you really need here is the a, and you've already pegged it, it's a minus 1. So the standard form for a quadratic function is this. F of x is equal to, anyone tell me how it begins? A times x minus h squared plus k. Perfect. So you see, the first thing we do to get this to look like this is get that a out of there, okay? Factor out the a from the terms that have x in it. And the a here is minus 1. Identify the a, minus 1, factor it out, okay? So I'll factor out a minus here. My parentheses will be x squared. You tell me what's next. Minus 6x blank minus 8. Okay? We haven't changed the function. We changed how it looks, but we haven't changed the function at all. Okay? Next step. Okay, first I'm going to bring down that minus sign before I do anything else. And what did you say? half of the b term here, the new b that we have in here, and that's a minus 6. And what's half of minus 6? Negative 3. Okay? Now, at that point, I stop and write down x minus 3. I just write it down right there because I know that's what I'm going to do next is going to produce this, and that's going to be squared, by the way. Okay? As soon as I see that, I write that down. Okay, so you got the minus 3. What do you do with it? Yeah, you square it. Okay, what's negative 3 squared? Plus 9. Okay. Now, what you've just done is change the problem. Whoops. Okay. But how did you change it? You added a 9 here, but that's inside parentheses with a minus sign out there. So that means you subtracted 9. Well, if you did that, in order not to change the actual value, you have to add 9 on the outside. So we're going to do that. Plus 9. Make sense? Okay. Now, if you wanted to wait till now, you could do it. You say, what did we do? We made this a perfect square trinomial. We completed the square. That's what we call this technique. Completed the square, and this is the perfect square of that. And this thing is always, once you pull out the a, then you just have an x here, and whatever half of this is, that goes right there. Okay? With whatever sign's appropriate, like this. Do it on the side, check it, and you'll see x minus 3 squared is that. Square the first term, x squared, twice the product of the two terms, that's where you took half before, minus 6x, square the last term, that's it. Okay. And then what do you have left on the outside? Plus 1. Now what does this tell you? It tells you the vertex is 3, 1. Ha! Good for you. What else does it tell you? Axis is? Say again? X equal 3. Always x equal whatever the h is. And that was the 3. X equals 3. All right. Now, we're ready to roll then. It says, sketch the graph, identify the vertex and the x-intercepts. We've already identified the vertex. We haven't sketched it, and we haven't done the x-intercepts yet. So let's sketch it. Okay? Okay. This is going to be a little awkward sketching. Hey, what I'm going to do, if it's okay with you, it rhymed a little bit, okay, is use that horizontal line I have up there as the x-axis. So let's just tick off a few points. 1, 2, 3, 4, 5, 6, 7, 8. Negative 1, 2, 3, 4, 5, 6, 7. Up 1, 2, 3, 4. Down 1, 2, 3, 4, 5, 6, 7. I'll use some minus signs, but that's okay. All right. What was your vertex? How do we get there? Go right 3, up 1. Just don't say yours. Okay. All right. 3, 1. There we have it. Okay? Now, I'm torn between doing it the easy way and the way I think the book wants you to do it. Okay. Here's the other thing I'm going to do. Oh, there's the vertex. We haven't indicated our axis of symmetry. Where is it? It's through that vertex, a vertical line through the vertex. There it is. There's your axis of symmetry. Okay? Say again? Yeah, got it. Thank you. Latricia, right? All right, good deal. Thank you. Okay. Now, my line isn't very vertical, but let's just pretend it is, okay? Now, here's why I did that. Because the next easiest thing to do, the absolute easiest thing to do is finding, and this is outside the completing the square method, this is finding the y-intercept. What's always true about the y-intercept? X equals 0. Okay? So go back to the original function here. Okay? Drake, right? Okay. All right. Go back to the original function, not your standard form, the original function here. F of x is equal to this. Don't forget that minus 8's out there, okay? Now, when x equals 0, that means that's 0 and that's 0. So what is your y? Negative 8. All right, I hope I have enough on here this time. 1, 2, 3, 4, 5, 6. Oh! You know, I'm going to cheat a little bit. I'm going to squeeze some of these in some, okay? I want that negative 8 out there, okay? That's why I moved my thing up. 4, 5, 6, 7, 8. Yeah, I got it in there now. If you can't do it otherwise, change your graph. Okay. So, 1, 2, 3, 4, 5, 6, 7, 8. There's your y-intercept. They didn't say anything about finding that, but it's so easy to do. Do it. Now, using the axis of symmetry, where is this point down here relative to the axis of symmetry? 1, 2, 3 places to the left, right? And since it's an axis of symmetry, where could I put another point without doing very much thinking at all? Axis of symmetry. 3 places to the right. So that would be 1, 2, 3 places here, come down to the same location, minus 8. There we have our second point. Third point. Vertex first, and then these two. Okay. That was so easy, I don't want to give up doing something easy. All right. Now, last time I showed you one technique for finding more points. But they want you to find the x-intercepts. What's true about an x-intercept? You just told me a y-intercept is found when x was equal to 0, so where might an x-intercept be? Where? What did you say? I thought that's where y-intercept was. So x-intercept would be where y is equal to 0. Now I want you to tell me what's my y. Question I told you from the very beginning, most important question in the course. What is your y? F of x! That's it! Right there. Okay? So what we do is set that equal to 0. 0 is equal to minus x squared plus 6x minus 8. We go back to that ax squared plus bx plus c. We do that form again. Because now this is a quadratic equation, right? And that's standard form for a quadratic equation. But what don't you like about that? What's the thing that really bugs you about this? I don't like leading off with a minus 1. Okay? Because I'm used to factoring, and that's not a minus 1. Okay, so how can you deal with that? Say again? Say again? Negate it? Did I hear that? Yes! Why don't we do that? Because you see, you can multiply or divide both sides of the equation by minus 1 because you have a 0 over here. That's not going to change the value. It'll just change how it looks. Oh, Zach decided he would show up today. How kind of you. Okay. All right. All right, so what I'm going to do is multiply everything on both sides by minus 1, and I'm going to flip them around as well. So I'm going to say x squared minus 6x, you tell me the rest of it, plus 8 is equal to, yeah, when you multiply by minus 1, it's still 0. Now that looks a lot better to me to factor than that did. Okay? I don't like that minus sign. Minus signs out there to trip you up, remember? It's the only purpose. Nah, I'm just kidding. All right. Now, you always try to factor if you can. Okay? You think you can here? We're going to try, aren't we? Okay, I call it unfoiling it. Okay? My first question is, what's the only possible factorization for x squared? X times x. Okay, write those in. We did the first term first. Now we're going to the last term, but we're not going to do that. All I'm going to look for in the last term is the sign of the last term. What is that? Plus. What does that tell you these two signs have to be? Ah, the same. They could both be both positive or both negative. That would still give you a plus here, right? Okay, then you look at the middle term, and that says it has to be negative, negative. Okay, so we got the signs. Now we ask the question, go back to the last term, and say, what's the only factors? You see a 4 and a 2. I couldn't even get the question out. The only factorization, or a factorization of 8 that gives you, that multiplies the B8, adds the B6, and that's going to be 4 and 2. Okay? Now what does that tell you? And you can check it, foil it, and see that's indeed true. X squared minus 2x minus 4x, that's minus 6x, plus 8. Yes, perfect. Okay, what does this tell you? What do you do next? You set each of those equals 0, because the only way you can get two numbers to multiply together to give you 0, one of them, or both of them, have to be 0. So either x minus 4 is equal to 0, or x minus 2 is equal to 0. Now, I don't have much more room at the bottom to write. Yep, it's not letting me. So let's do it. What's that? X equal 4. Well, let's go up here to our graph. 1, 2, 3, 4. Hey, there's x equal 4. Y is equal to 0. And then when the second one gives us x equal 2. 1, 2. There we have it. There's our two x-intercepts. X-intercept here is 2, 0. X-intercept here is 4, 0. Because your y was 0. Remember, that's the first thing we did. We set y equals 0. That's how we got those two. Okay? Now we'll go back to my technique of finding another point or two. Okay? Now I like to go to this form here. Pick a point that you already know. Okay? You know 1, 2, 3, 4, 5 points so far. Pick any one of them that you already know. In fact, I would pick one of this one, that one, this one, or that. That one up top, we already got the ones on either side of it, so let's not mess with the vertex anymore. Okay? Pick one of these other 4 points. This one, that one, that one, or that. Pick one. You choose. Say again? The what 0? 2, 0? Is that what you said? Okay, yeah, 2, 0. Fine, okay. We already know what's to the right of it. That's our vertex. So what we want to know is what's to the left of it. And that's going to be 1, right? X equal 1. So come down here to this form here and put x equal 1. 1 minus 3 is negative 2. Squared is plus 4. But you negate it and you get a negative 4. Then add 1 to it and you get negative 3. So when x equal 1, y is equal to negative 3. And then, oh, that's right in my R for my vertex, okay, but that's where it is. But now, because of that beautiful little axis of symmetry here, I don't have to do any more thinking. All I have to do is, what? Go 2 points to the other side, and that gives you another point. So 1, 2 here, 1, 2 there. There is your equivalent point over here. Here is your graph. It's coming from somewhere down here, going up through this one, through that one, smooth around there, and back down again. There it is. Not that bad, was it? Now, you probably could have drawn it just with the vertex, your x-intercept, especially if you use that y-intercept and that. You could have drawn it from there, but this just gave you another point to try to aim for. And it works nicely. Any questions on that? I know some of you already started working on your checkpoint last time, so please do the checkpoints. Okay, they also skipped example 4. Any questions on this? Can I erase? Okay, let's go on to example 4. Okay. Uh-oh. This isn't fair, is it? Before they gave us the equation, they said graph it. What they're doing now is saying, here's the information about it, you write the equation. But not just any old equation. We want it in its standard form. So we want the standard form for the quadratic function whose graph, and we'll get to that in a minute. How does that standard form for a quadratic function look? F of x is equal to a times x minus h squared plus k. Good, y'all got that one. Okay. Now here's what we know about it. They don't even they show us the graph later, but they don't even give it to us to begin with. They say whose graph is a parabola. Oh, what a surprise. If it's a quadratic function, it's got to be a parabola. With a vertex, but they do give us a vertex, and the vertex is 1, 2. Buckle my shoe. Okay. And it passes through the point 3, negative 6. Okay. That's all they told us. But you know what? You can give me one other piece of information, can't you? If what? The what? Axis of symmetry. I'm going to call that the AOS because I get tired of writing axis, okay? Axis of symmetry. What would it be? X equal 1. Exactly. Perfect. Because it's your H. Okay? Oh, I can't go away, did I? I should have asked you, what do these things stand for? What's your 1? H. What's your 2? Okay. Look at that. You can write that in right now. Without doing hardly any thought at all, you can write this in. So this function, f of x, that's what they're asking for, is equal to a times x minus 1 squared plus 2. You know you're 2/3 of the way to the answer just from that. Just from that. But, unfortunately, we've used everything we can get out of this. But we haven't used this at all. Right? Now, what it means to say that point is on the parabola, that means those values fit this equation. But you have to remind me, what in the world is that f of x? Y. And where do you see a y here? Negative 6. Okay? So let's write that down that way. Your y here is minus 6 is equal to a. We don't know what a is, so leave that alone. Times, and what's your x? 3 minus 1 squared plus 2. So here's an equation with one variable, a. If you solve this equation, you know what a is, right? So let's do it. What you want to do first? Yeah, in the parentheses, 3 minus 1 is 2, and 2 squared is 4. So that's 4a plus 2, right? Okay, I'm sorry, I did 2 steps at once. Do it in parentheses first. 3 minus 2. 3 minus 1 is 2. Square 2 and you get 4. That's the coefficient base, so I wrote it in front. You could have written a times 4, but I like 4 in front. 4a plus 2 equal minus 6. I don't think that one's too hard to solve. What will you do next? Subtract 2 from both sides. And what does that give us? Negative 8 is equal to 4a. Done, because that adds a 0. And now what? Divide by 4, and that gives us a is equal to negative 2. So now go back and plug that in this function here. F of x is equal to a is negative 2 times x minus 1 in parentheses squared plus 2. And guess what? It's already in standard form. You're done. Okay? Done. That's the answer. Now, they wrote it wrong in the book, didn't they? At least in my book they did. At the end of the problem, they say the function in standard form is f of x equal minus 2 times x minus 2 squared. Where'd they get that? You know, plus 2. They wrote that. It should be an x minus 1 squared. Y'all see that in your book? Huh? Oh, it's right in the e-book. Is it right in your text? It does say negative 2. Okay, the e-book got it correct. Go E! Okay, but the printed book got it wrong. Sorry about that. A lot easier to change an e-book than it is to change 4 million copies of a paper book. Okay, so if you have a paper book, you'll see it is wrong, but it's correct on the e-book. Okay, now, we didn't use the axis of symmetry unless you wanted to plot it. And when I go to plot this one, I will put my x-axis up here, do 1, 2, 3, 4, 5, 6, negative 1, 2, 3, 4, 5, 6, 7, positive 1, 2, 3, negative 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now, plotting the first value, the vertex is 1, 2. How do I do that? Help me. Vertex, 1, 2. Okay, which way is over? Right 1, up 2. Got it. Right there. Okay? Now, all they gave us to begin with was 3, negative 6. How do you do that one? Right 3, down 6. 1, 2, 3, 4, 5, 6. Down here, just about there. Okay? Now, here's where it comes in handy to use the axis of symmetry. That's at x equal negative 1. That's going to be a vertical line through negative 1 and through the vertex, by the way. Okay? And then here, you notice this point is 2 to the right of that, so you go 2 to the left of that, and you've got, I'm not quite on the money here, but somewhere right about there. There's the second point. Okay? And you can go back and fiddle around and get the rest of them if you wanted to. You can go 1 over from your vertex. That's at 1. So go 1 to the left. And 0 minus 1 is minus 1. Squared is? Okay. Is what? 1. And 1 times minus 2 is? Minus 2. Plus 2 is? 0. So 0, 0 is on there, and because of the axis of symmetry, give me another point. Give me another point. This is 1 to the left of the axis of symmetry. Go 1 to the right. 2, 0. There it is. Okay? You just found your x-intercepts without having to factor a thing. Okay? Now, if you preferred the factor, you could have factored. Okay? But you got them this way. In order to factor this one, you'd have to go through and multiply all this stuff together, get it back in ax plus bx plus c form, and then factor it. So much easier to just go right, left. And you happen to hit the x-intercept. You don't always. Sometimes you have to factor. Or sometimes factoring doesn't work, and you have to use quadratic formula. But we'll get to that later. Okay. Any questions on that? And from there, you can draw pretty much your graph. They didn't ask you to, but there it is. Okay, does that look like it could be right? Well, number 1, your A is negative, opening downward. Okay? Number 2, A is a number larger than 1. I mean, the absolute value is greater than 1, so that means it's vertical stretch. And that sure looks like it is. Okay? And then everything else seems to fit. So yeah, I feel pretty good about it, and it looks a lot like the one in the book. They didn't show all the points we did, because we used the axis of symmetry to get a couple more points. Any questions on that? Make sense? It's a lot of fun, isn't it? I can tell y'all are excited, no end. Okay. So, let's move on to finding minimum and maximum values. Oh man, on a parabola, where might be the minimum or the maximum value? At the vertex, it's got to be, okay? That's what the vertex is. On a parabola, that's what it is, okay? So, we already have a way of finding it. Do your, get it in standard form, and that gives you the vertex. But guess what? We're going to find an easier way. Y'all like easier ways? But sometimes to get that easier way, you have to make it a little harder. But once you got it, you don't have to go back and do it again, okay? So that's what we're going to do now. We're going to go through some gory detail to find an easier way. Many applications involve finding the maximum or minimum values of a quadratic function. Sure, you can complete the square and find the vertex that way. You know that's got to be a max or min. How do you know if it's a maximum or a minimum? Yeah, it's what your A is. If A is negative, that's going to be a max because it's opening down. If A is positive, that means it's going to be a min because you're opening upward. So yeah, you use the combination of your vertex and your A, okay? And that tells you. If you do it that way. But let's see if they can find an easier way. By completing the square again, well, we had to do it anyway to find the standard form, but let's do it without numbers. Let's just use it using the A, B, and C. Now, they stand for numbers, sure, okay? But we can't multiply and divide them. We just have to write them down. So here's what we do. First thing is factor out the A, remember? Okay? So let's do it again in gory detail. All right? Now, they forgot to put their blank in there, so let's do it up here. F of x is equal to ax squared plus bx blank plus c, right? Now you factor out an a. Well, factoring is the same basically as dividing. So it's going to be a times x squared, because a divided by a is 1. And here it's plus b over a times x blank plus c. Now, if you don't believe me, distribute. A times x squared is ax squared. Yeah, that's right. A times b over a, the a's cancel out, you get bx plus c. Yeah. So you haven't changed the thing except how it looks. Okay? Now, what was the next step? To complete the square. You tell me. What have we been doing? Done about twice this morning and a couple times on Tuesday. What's the next step? Half of b over a. Well, that would be b over 2a, wouldn't it? Okay? So I'm going to write down x, and it's a plus b over 2a. Okay? And write the square. I know it's going to turn out that. But what do we do with that b over 2a? Square it. So that will give you a plus b squared over square 2, you get 4, and square a, you get a squared. Ew. Okay? Now, what you've just done, let me erase this little line that I put in there. Okay. Looked like a parenthesis, but it wasn't. Okay. You have just added a times this, which is b squared over 4a, because a cancels one of those a's out there. So we have to subtract a b squared over 4a for a. Frankly, we don't even care about that. It's awkward. Who cares? All we're interested in here, you'll see. So let me write this down. So what we have here is plus c minus b squared over 4a. And we are not even going to worry with that at all. Okay? Because all we're interested in, this, by the way, is our k. I'd much rather have k than all that mess. But this right here is my, if that's my k, this is my h. only it's the opposite of this, so it's a minus times this. So right now we know that H is equal to minus B over 2A. And you know what? That's pretty easy to remember, isn't it? Minus B over 2A. Now, didn't we write down the quadratic formula before? You remember that? Okay. Does anyone remember what it was? This is completely off the subject, but there's a reason for it. Quadratic formula is x is equal to minus b plus or minus the square root of b squared minus 4ac all divided by 2a. And again, I'm not going to worry about that complicated looking part. I want to look at just that constant in front. What is that? Minus b over 2a, isn't it? The same thing we've got here. So that's not going to be hard to remember. It's minus b over 2a. That's your h. Now, what's your k? I don't care what this is. That's just too much work to do that. So what I'm going to do is take this h, plug it into my L, and I'll find out what it is. And that's how we're going to find our maximum and minimum values. Now this is I'll let them show you. Okay, can I go on to the next slide? Okay. So the vertex of the graph is the h is minus b over 2a. And then the k is, rather than writing all that other mess, just write the function, evaluate it, minus b over 2a. That's usually easier to do than doing all the other things. Okay? Because h, k go together and they have to be in the function. So this implies the following. The minimum and maximum values of a quadratic function, consider the function f of x equal ax squared plus bx plus c. That's our standard form for a quadratic equation, but written as a function. It's not the standard form of the quadratic function. But now, rather than having to complete the square there, we've already done it once, and we know the h value is going to be minus b over 2a. So whatever this is, negate that, divide it by that. No, twice that, okay? Now, once you have that, plug that in here for x, and that's where you get your k. Okay. But then all you have to do is look at your a, which we already said before. If the a is positive, that means it's opening up. This is a minimum at x equal minus b over 2a. And the minimum value is your k, f of x, minus b over 2a. But if that a is negative, less than 0, you know it's opening down. That means that's the maximum when you're at your vertex. X equal minus b over 2a, and the maximum value will be there. Okay. A lot of letters. Let's actually do a problem with it. And this is sort of a fun problem, a real life type problem. Not for me, I don't hit baseballs very well. Okay. The path of a baseball after being hit, which I seldom do, is given by this function. Oh, you knew that, didn't you? All right. Minus 30 is 0.0032 x squared plus x plus 3. Okay. Now, you don't need to know where the formula function came from, but it's there. I'll give you a hint. This is just a hint. This, I can tell, looking at this formula, is in U.S. customary units of feet per second squared. The acceleration due to gravity is feet per second squared, which is 32 feet per second squared. And it's also a minus. So that's where the minus came from. That's where the 32 came from. I can't tell you easily where the decimals came from, but that's where the 32 came from. Okay? I'll also tell you, well, this is a lot harder to see, but the initial velocity was 100 feet per second. And how I know that is because this is 10,000 this way, so that's what would have made 100 that way. And I also tell you the ball was 3 feet off the ground when I hit it, because when x equals 0, the y was 3. So that's where it was when whoever hit it, okay? So f of x is the height of the baseball in feet. I told you that. Height of the baseball in feet. X is a horizontal distance from home plate in feet also. That's why I said when x equals 0, when it's right at home plate, it was 3 feet. The ball was 3 feet above the ground. That's where you hit it. The question, though, is what's the maximum height of the baseball? Okay? Well, this is a quadratic function, right? And the a is what? Negative. So that means it's going to be going up. So that's going to give the maximum height. So, do you want to try completing the square with this one? Please say no. All right? I don't want to do that. I don't want to factor this out of that, and ooh, what a mess. But, since we've already done that work once, we know the h is what? Give me that formula we just derived. Minus b over 2a. So it may be helpful to identify what's your a? Negative 0.0032. What's your b? 1. And who cares about c? Okay, we don't even going to use it. It's 3, but who cares? All we're going to use is this one. Okay, so let's plug it in. It's going to be a minus 1 over twice that thing. Twice that thing is going to be a negative 2.2. I'm sorry, I can't write. I can't talk. I can't do anything. Okay. We're going to double that number a. Okay. When we double that number a, it's going to be a minus 0.0064. Okay? Now, the easy thing to do next, count your number of zeros. There's 2 of them. That makes them positive, right? If it was an odd number of zeros, it's going to be negative. Even number is going to be positive. So that's going to wipe out your negative sign. Yay! All right. Then pull out your handy-dandy calculators and do 1 divided by 0.0064. Like I told you before, be sure you bring calculators to class, to test, to everywhere. And what do you get? 156. Is that what you said? Yes. 156. And that will be, say again? 0.25. 0.25. Okay. 156.25. Yes. That is your x. But that's not what we're looking for. X is how far you're off from home plate when you're at your maximum value. So to get the maximum height, the height is your f of x, you see? So what we do is plug that in. So f of 156.25 feet, that would be in feet, okay, is equal to negative 0.0032 times, minuet, okay, all right, times 156.25 squared, I'm going to leave off the units, okay, plus 156.25 plus 3, okay. Again, you got your calculators out there. You probably already have that 156.25 on your screen. So square that, multiply it by negative 0.0032, add to that your 156.25, and then add 3 to that, and see what you get. Ooh, a lot of work there, isn't it? But it's easy. Y'all, your thumbs are good. I've seen you on your phones before. You can punch that in, no problem at all. Me, I don't have those kind of thumbs. Okay. So if you already had the 156.25, if you didn't erase it, just square it. And multiply that by a negative 0.0032. And then add to that 156.25, and then add another 3. Or if you wanted to, you could just add those together, make the 159.25, and that way you don't have to put it in. Punch your thumbs as many times. Anyone get an answer yet?
81.
Oh, 81.125, and that's also in feet. That's how high that baseball is, okay? That's about 9 yards, because there's 3 feet in a yard. Yeah, no, that's not right. 27 yards high, okay? 3 will go into 81 27 times, so it's about, whoa, that's up there, isn't it? Okay? 27 yards. Whoa, that's a quarter of a football field up in the air. That's pretty high. Okay, there's your answer. Did you have to complete a square? No, because we completed the square when we came up with this. So we just use this from now on. Now, if you would rather, you could go back to that, what was it? C minus B squared over 4A, plug that in, you'd have gotten the same answer. A lot easier just to plug it in. The equation here, get your answer. All right. And that's what they got too. And guess what? They have on the checkpoint another baseball being hit. Okay? All right. That ends section 2.1. Any questions on this problem or any of the others? Got it? Yeah. Is there a question?
Yeah, it's a question.
Okay.
So I was trying to last night the sketching graph of quadratic function.
The what?
Sketching graphs of quadratic function. And I got
Sketching graphs of quadratic functions.
Oh, doing graphs of what? Is that what you're saying? Okay. Which one? Oh, sketching graphs of quadratic functions. Now my hearing's making sense. Okay.
that number 9 on the exercise.
On page.
On
Okay.
page 120.
On page 120, number 9. Okay. Let's do that. Okay. Or at least do a couple of them. Let me see if I can find more white space. Maybe not. Oh, I went the wrong way. Oh, wait. Before we do that, I'm sorry. Let's see how they did this. Okay. For this function you have, they wrote it in not standard form, but the old form, ax squared plus bx plus c. I went the wrong way. All right. And that was minus 0.0032 x squared plus x plus 3. That implies that a is this and the b is 1. Notice they didn't even worry with the c. We're not going to use it in this case. Okay? And because a is less than 0, you know this is going to be a maximum. So we already got that. And it'll be when x is equal to minus b over 2a. So the baseball reaches its maximum height when it is x distance from home plate, which is minus b over 2a, which is minus 1 over 2 times a negative 0.32. See, they wrote out that step. And then they didn't write out the other steps. The 2 negatives cancel out, and then you get 156.25 feet from home plate. Then, rather than going back and doing that other part, they just plug this into the formula. Alpha of that value is going to be 81.125 feet. Okay, that's the last slide. So let's use this part for our page 120. This is 2.1 exercise, and this is number 9. Sketch the graphs of a quadratic function. In these, sketch the graphs of each quadratic function. Compare it with the graph of y is equal to f of x. Oh, this is number 9. Okay. So y is equal to x squared. What I said f of x. Of course it is. It's always that. X squared. Let's graph that one first. Okay. So. Okay. Here will be my graph. Actually, I'll use that as my graph, okay? 1, 2, 3, 4, 5, 6, negative 1, 2, 3, 4, 5, 6, positive 1, 2, 3, 4, 5, negative 1, 2, 3, 4, 5, 6. So, okay, whatever. All right, let's do y is equal f of x. Give me some points for that one. Y is equal f of x. I want some extra points. No, I'm sorry, that's not what I meant. Okay. Give me a value. Give me an x. 1. Okay. I heard a 0. We'll come back to 0. 1 squared is 1. So 1, 1 is on the graph. How about that 0? 0, 0 is on the graph. Give me another one. Negative 1 what? 1. Got it. Give me another one. 2 what? 4. 1, 2, 3, 4 up there. Okay. Give me another one. Negative 2. 4. Got it. Okay. Can't go any further. So there's my graph. Ooh, it's a pretty ugly parabola, isn't it? Don't answer that question. Okay. There's my parent function. Okay. So you want to do the a part. 1/2 of x squared. F of x is equal to 1/2. Whoa, wait. I need you to give me a color first. Give me a color. Red. Okay, we'll do that bright fire engine red. Okay. F of x is equal to 1/2 x squared. Okay? Yeah. How would I graph these points? Well, the x's are going to be the same. It's just the y is going to be half of the other one. And what's 1/2 of 0? 0. What's 1/2 of 1? 1/2. 1/2 of 1? 1/2. 1/2 of 4? 2. 1/2 of 4? 2. Okay? If we had gone a little further in the first one, and we can do it now, x equals 3. 3 squared is 9, and half of 9 is 4.5. 1, 2, 3, 4.5. So that would have been 3 there. I can't see it. No, who chose red, huh? Okay. I'll put it right there so you can see it. It might not be in the right place, but that way you can see it. So here is your F. Somewhere up there. Okay. I can't see it. Okay. Let's do the B part. What color you want B to be? Say again? Green? Is that what I heard? Okay, green. I'm going to do the darker green. Is that okay? So the B is going to be G of X, G for green, G of X, y'all are really color coordinated, aren't you? Is equal to negative 1/8 of x squared. You know what? I'm going to have trouble doing this one. I'll do the first one part. 1/8 of 0 is 0. 1/8 of 1 is 1/8, which would be somewhere down here, right? Okay. And 1/8 of the other one would be somewhere down there, okay? And that one disappeared, okay? Now, 1/8 of 4 is what? 1/8 of 4. Is what? 1/2? Yes. That would be right here. And that would be right here. Oh, you're absolutely right. Who is your instructor that can't pay attention? Okay. It's going to be, oh, I erased the whole thing. Okay. All right. You're absolutely right. That one was negative. I'm going to have to go back to black here so I can put my axis back in. Well, it didn't come. Get out of there. Okay. All right. Oh, Oh, I wiped out this one too, didn't I? Both axes went away. Okay. Now we'll go back to green. And you know what? I erased more than I thought I did. Okay. Back to black here. This one is still in there. And the black dot is there. The red dot is there. And the green dot is still there. Because the 0, 0, I didn't have to erase that one. I would have saved myself a lot. So it's minus 1/8, which would be right about here, and minus 1/8 here. Minus 1/2 here, and minus 1/2 here. So now we just keep going. When x equals 3, that would be 9. Negative 9/8 is just a little bit more than 1. So that'll be here and here, right? The next one would be a lot better. When x equals 4, x squared is 16. 4 squared is 16. And negative 1/8 of 16 is negative 2. So that would be there and there. Okay? And then the next one out would be 5. 5 squared is 25. 1/8 of 25 would be 3 1/8. Right? 24. Okay, so it's 3 1/8. So it'd be just past 3. So that would be here and somewhere about here. Let's see if we can do 6. 6 squared is, whoa, I didn't get that one right, did I? I didn't go out to 5. There. That was really poor. Okay. 6 squared is what? 36. 1/8 of 36. Ooh. Ew. About, no, 3 1/2, no, wait. Yeah. Yeah, 4. No, wait. Okay. 36 divided by 8. That would be 4, yeah, 4.5, right? 1, 2, 3, 4.5. That would be out here. Thank goodness we're running out of room. Okay. I'm not sure I could have done many more. Okay, here. So here is that parabola. Now notice what's happened here. The minus sign negated it, flipped it across the x-axis. The small number here squished it. Vertical shrink. Okay, and that definitely is a vertical shrink. Okay, that was the B. You see what's happening with those? Okay, the next one would be 3/2. That's going to be a slight vertical stretch, but upward. And the next one after that is a minus 3x squared. That's going to be a flipped and also a vertical stretch downward. Okay, does that answer it? All right, painful but true. Okay, any other questions? So let's do vocabulary, top of page 120. Linear, constant, and squaring functions are example of what kind of functions? Okay, no, only the squaring is a quadratic. Linear and constant are not. They're polynomial functions, absolutely. Number 2, a polynomial function with x of degree n has the form of f of x equal a sub n x raised to the nth plus x a to the n minus 1 times x raised to the n minus 1 plus dot 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 down to a sub 1 times x to the first plus a sub 0 times nothing, where a sub n is not equal 0, where n is a blank blank. To be a polynomial function, n has to be a positive integer. Positive integer. And a sub n minus 1, and all those a's there are what kind of numbers? Blank numbers. Not imaginary. Real numbers. Okay, good. Number 3, a blank function is a second degree polynomial function. That's what you were answering earlier. What do we call a second degree polynomial function? What was the name of the section? Quadratic function, okay? And its graph is called a parabola. Excellent. Number 4, when the graph of a quadratic function opens downward, its leading coefficient is blank, negative. And the vertex of the graph is a maximum, yeah, the greatest point. Okay, homework exercises here. I would do all 4 of 5 through 8. Only the odds are in the back and at calcchat.com, but they are so easy. Do all 4 of them. Then do either 9 or 11. We just did 9, so do 11. It's at CalcChat. Any of the odds 13 to 25, they're all at CalcChat. 17's at CalcView. Any of the odds 27 to 33, they're all at CalcChat. 35's at CalcChat. Any of the odds 37 to 45 are at CalcChat. 37's at CalcView. 47, 49 are at CalcChat. 51 through 55 are at CalcChat. 57 to 61 are at CalcChat, but 57's at CalcView. 63 or 65 are both at CalcChat. 67's at CalcChat. Then do any of the odds 69 through 73. They're all at CalcChat. You can explore doing the true-false. 75 is at CalcChat, should be. And you can think about doing 77 or 79. They should be at CalcChat. 81 is a proof. You can try that if you'd like. We'll begin next time with 2.2. Any questions? All right. Have a good weekend. Of course, doing pre-calculus problems will make it a good weekend, won't it? All right. Good deal.